Hello, engineers. Welcome to MSDD 5000 for Mathematical Methods for Data Analysis course. And my name is Adesa, and I'm the instructor of this course. This course is about mathematical methods for data analysis, which is quite a big topic. So it is impossible to cover all of them in the one video. And so I said I said you once again. Uh, my name is Ajay Shah, and I am the instructor of this course, and I am also founder of Cyber. Sorry, I am also founder of Asia Technology Software Solution. This is my online company, and I'm developing is iPhone operating system iOS application and Android applications, and also websites, web development, and and I'm hosting also servers and websites. Uh, so without any delay, any questions, let's start the question. Let's start the course. Uh, in the following 8 weeks, we will mainly focus on mathematical tools for machine learning. To this end, I would first like to give you an overview of which mathematical tools will be involved in machine learning and data science. Let me start with the typical machine learning machine learning tasks. And following 8 weeks, we will mainly focus on mathematical tools for machine learning. To this end, I would first like to give you an overview of which mathematical tools will be involved in machine learning. Let me start with the typical machine learning tasks. And so MSBD 5000 for methods for data analysis, and HKUST math introduce mathematical tools for machine learning of HKUST math. So the first machine learning task I would like to discuss is supervised learning. In supervision learning, we are giving a training data set in the form of input output pairs, and so here is given xi and yi, and I is equal to 1. I is equal to 1 and 2 and dash 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 m. So xi, uh, this xi is input, and this yi is output level. It is input, this is input level, and this is output level. So xi yi, and we have many pairs of data. So I is from 1 to m. Here is x, here is xi is the input. Okay, here is xi is the input. It is some kind of features. It could be in many different forms. It could be a vector, a matrix, so, or even a text, paragraphs. Yi here is the corresponding output or the level of the input. Here is yi. Here is yi. It can also be in many different forms such as binary values, real numbers, and so on. With this training data set, our goals is then to find the relationship between uh, the input and the output. So from mathematical point of view, we want to find a function f reflective the relation between the input and the output. So mathematically, this f function should satisfy f x I is approximately yi for all I. Here is given. Find a function of f stf, and this is xi implies yi, and I is equal to 1 dash 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 m. So if a new input x come in, we use f x is the prediction of level of x, example r. So mathematically this f function should satisfy f bracket xi is approximately yi for all I. And now once we have found such as function f, if we have a new feature input x come in, then we can use f bracket s uh, f bracket x is a prediction of the level of x. So this is a typical supervised learning task. This problem is called a data fitting problem now. So let me show you an explicit example of supervised learning recognition of handwritten digits. The training data set in the recognition is shown here. The input are the image of handwritten numbers, like this image is x1, this image is x2. So this image is x1, this is x1. This image is x1, and this is x1, and this is x2. Yeah, this is x2. This is x1 and this is x2. On the corresponding yi are the corresponding recognition of the digit contained in the image. For example, for example here is y1, y1 is 5. For example, here this y1 is 5, here this y1 is 5, uh, because obviously we have a number 5 contained in this image. This is y2, and this image is y2, this image is y2. this image is y2. Content in this image, this y2 is 2 because obviously number 2 is content in this image. Content in this image. Okay. So from this data set, you can see that we have 25 input output pairs. Then in this example, m equals to 25. M equals to 20. uh, Here is given m equals to 20. Okay, m equal to 20. Now our goal here is to find a map from the image to the number or the levels. So we want to find a functions that map the image to the corresponding number contained in the image. Contained in the image. So therefore we need to find a function f such that f applies to the uh, image equals to the level, or more rigorously we want to f applies to x1, to x1 sorry to x1 is about y x sorry xi is about yi for all i, and giving a new image, we simply apply the derived functions. So we use here, uh, therefore we need to find a function f such that f applies to the image equals to the level, or more rigorously we want f applies to xi is about yi for all I. Xi is about yi for all I, and to that image to obtain the number contained in that image. For example, if we are given this image, then we use f of this image, this image. Now we discuss another machine learning task, unsupervised learning. For uh, un- for unsupervised learning, we are giving only the input data xi without labels. So therefore, unsupervised learning is more challenging than supervised learning. The goal in unsupervised learning could be quite different, based on different applications. For example, we may be required to find the common features, find common features. Sorry. Uh, so here is that. Example 2, given some picture of human faces, I have already given here. And at last questions, and the last questions, find some common features from these known pictures. These pictures, okay, these pictures. This no human faces. This is like human face. This is and this is human faces. This is and also this is human face. Then we can use those common features to produce a face that does not belong to any real person. Can we do that? The answer, of course, is yes. Nowadays, actually, we can use the called generative adversarial network or uh, variational autoencoder to generate those artificial faces. Generative uh, adversarial network, GAN, or uh, variational autoencoder, VAE. The idea behind GAN and VAE is uh, G sorry G A and G A E, GAN and VAE. GAN and VAE is a flaws. First, we learn some parameters from those pictures. Then we use those parameters to regenerate some new faces. Here I will show you some result uh, from GAN, some result for GAN. You can see here these three faces. These three faces, you can see here, these three faces uh, are all perfect artificial faces. Those three example are three typical problems in the machine learning, and you should be very familiar with it. And so I'm ending this class, and tomorrow I will bring next topics of video and next courses. So if you didn't understand any topics, then you can message me and comment me. You can comment me, and so I'm requesting you, don't forget to subscribe our channel, and please subscribe our channel and press the bell icon and save all playlist. And thank you for watching, and keep learning. Bye bye. See you later in next video.